Good morning! Today we are going to present you our research, Bio-Surfactant-Enhanced Meat Analog, a novel approach to low-fat isolated food. We will start with the introduction and the problem we lead up to our project. In recent era, it is undeniable that meat is the main resource for humans, but raising livestock farming can cause greenhouse gas that remarkably affect the global warming. Plant-based meat can significantly tackle this issue. Moreover, to solve the problem of iron intake that is normally obtained from meat, iron is added in meat analog. Typically, artificial meat are blended with a certain amount of oil to improve the juiciness of the meat. However, in order to find a way to reduce the amount, surfactants are used instead. Hydroxyl cellulose, HEC, acetylate starch, ACT. Because of the long carbon chain do not like water, the OH group can bind with water, giving them emulsifying properties. Objective: to develop a meat analog formula based on physical properties and textures of the meat, using soy protein isolate, with a focus on replacing oil with bio-surfactants while maintaining nutrition volume, and providing a taste and texture similar to consuming the meat. In addition, is added in meat analog. About the methodology, this table shows the formula of ingredients for making meat analog in this work.
This methodology outlines the step preparation of a formulated product. It begins with measuring ingredients which are mixed with soy protein isolate and heated in water bath. Biosurfactants, oil, and beetroot are then added in sequence. The mixture is molded, refrigerated, and evaluated for other evaluation. Because we add biosurfactants in order to replace oil, so we investigated the oil holding capacity or HC% to determine the ability of a substance to retain oil after processing. The experiment used the weight determined before and after the centrifugation to separate oil and water treatment. The oil holding capacity is then calculated using the formula by this equation. This slide shows the sensory evaluation, which is a method used to assess food characteristics like taste, smell, color, texture, and overall liking. In this case, 10 female teenagers evaluated meat analog sample using a 9-point hedonic scale, ranging from 1 to 9. Results have improved product quality and customer acceptability. This slide shows the texture analysis, which is for evaluating the mechanical property of meat analogs using 1 cm cylindrical probe. Force is applied to the sample and its response is recorded in a graph. Key parameters 7 volumes, then analyzed. This process ensures consistency and optimized texture in food products. Here's the result part showing an example of a meat substitute using different emulsifier. This is a result critical concentration, which is an important parameter in determining the effectiveness of biosurfactants in various applications. The critical concentration of hydroxyl cellulose biosurfactants is identified as 0.7 gram per ml, while for acetylated starch is 3 gram per ml. The results show that the hydroxyl cellulose formula has the highest oil holding capacity with the lowest percent HC, followed by acetylated with a slightly lower but still higher than the control formula. This high oil holding capacity in hydroxyl cellulose is due to the biosurfactants, which improve the protein structure, enhancing its ability to bind water and oil effectively. This results in a juicier texture and firmer structure.
Next, the acid of iron content in 3 analog formulation revealed that the biosurfactant hydroxyl cellulose effectively retains iron, followed by acetylate and control. The higher iron content in hydroxyl cellulose may be due to its component, which helps stabilize iron, enhance its solubility, and prevent precipitation more effectively than the outer formulation. Together, the iron content in hydroxyl cellulose meet the daily iron requirement, making it a good option for iron-rich meat analog. The sensory evaluation results suggest that the acetylate formulation is the most preferred among the experimental sample, particularly in terms of flavor and texture. This table shows the texture profile analysis, confirm that the acetylate formulation closely resembles the commercial product, making a strong candidate meat alternative. With good resilience, no fracturability, and optimal balance of cohesiveness, gumminess, and chewiness, acetylate starch provides stable relative texture, making an excellent candidate for high-quality meat substitute.
And next, we will talk about the price of plant-based meat and real meat sold in general market. Compared to 150 grams that is popular of selling separately, it was initially thought that the price of plant-based meat in the market normally $1.14, which is slightly higher than real meat. $1.19. It is expected in the future, meat analog may have a low price because there are developments and study for many research projects, which can help reduce the experiments that have already been done, making the process less complicated.
Finally, here's our conclusion. Firstly, a plant-based meat analog was successfully developed using biosurfactants, maintaining good water retention and texture while viable meat alternative. Next, the product is rich in iron from spinach and supplements, offering a beneficial option for dietary iron intake. Further nutritional analysis is needed. And the last, sensory evaluations show moderate acceptance, especially in color and texture. Further improvements are needed to enhance taste and optimize its role as a functional food. This is our references, and we would like to thank all these supports. This project would not happen without them. Thank you for your kind attention.